Hello, I'm Navya Majji, and this is my lab report for our third lab on circuits. Let's begin with an introduction of the lab overall. The purpose of this lab was to predict circuit behavior with resistors in series and parallel, use multimeters, and examine the behaviors of the resistors and capacitors. The results of the lab include that a light bulb gets duller and then brighter when connected only to a capacitor. When connected to a battery, it has a similar behavior but in the opposite. I want to begin with some of the models and fundamental physical principles used in this lab. We use the loop rule, which mentions the principles of energy conservation. Voltage in a circuit loop is conserved, as shown in this first image here. And another thing we applied was the junction rule. So current is conserved in a junction too. So the I, or current that enters a junction, has to be equal to the I, or current that exits a junction. And we can connect these two rules and use them and see different kind of things with them with Ohm's law, which is represented here with V equals IR. So we would use the loop rule because in a circuit we can measure the voltage, we can measure the current, and so the loop rule is applicable that way. We can measure the current as well, I, with different tools, and then we can connect them with voltage because we know the voltage in a circuit with the battery. So let's talk about some of the initial conditions of this experiment. Our system really just included a battery, resistors, and light bulbs, the capacitor, and all the experiments combined. Initial conditions were that the battery was at 3 volts and the capacitor was uncharged. In the second experiment, in the first experiment, it was just the battery at 3 volts and the ammeters calibrated to our best attempt at 0. And the details of the systems and surroundings were just a regular lab experiment. Nothing really could have impacted the lab too much because we weren't interacting with anything. We used ammeters and voltmeters in the form of a multimeter to measure the quantities discussed. So then we can talk about the details of the experiment. This setup was similar to our setup for the first experiment. We've had to go in and find the value of a resistor using the bars on it and stuff. So we have assembled the circuit with physical components such as 2 resistors, ammeters, 2 batteries, and measured the circuits at the location, measured the currents at the location of the ammeters. In the second experiment, it looked similar, but rather than have ammeters, we had a light bulb and a resistor and a capacitor, and we charged up the capacitor, and we just found how long it took to do that. So for all the experiments, the sources of error, there really isn't much room for human error, but the equipment we might have used might have been faulty. The multimeter may not have been calibrated perfectly. The resistor's battery and capacitor may not have been in a perfect condition, just because over time they get used up, and the metal parts of the resistor were kind of bent up. So let's answer some of the questions mentioned in the lab document. The sum of potential differences should be equal, theoretically, to the voltage of the battery, which is the total voltage of the circuit at 3 volts. Our value was at 2.97, which is pretty close. And to answer the second question, the voltmeter isn't actually changing the experiment, and the ammeter reading doesn't change because the current in the circuit doesn't change. It's just reading it. It's not actually going in and changing any values. And to answer the third question, we kind of have to dig into our experiment results. When the light bulb is connected to the battery and the capacitor starts bright, but then it decreases in brightness, and then as the capacitor gets charged. When we unplug the battery and just have the capacitor light bulb system, our currently off light bulb turns on as the capacitor discharges and then eventually dulls out. And we changed the bulb. It did the same thing faster because it had more power in it. And here's a video. It's very dull. You have to notice carefully, but it starts out dull, it's going to get brighter, and then it's going to get duller as the capacitor discharges. So, and this makes sense because the capacitor has a finite amount of charge that it's spreading around. And that is all. Thank you so much.